the red subscribe button right under the video and also the bell icon to get notification on any of our latest updates on the videos.
Good day everyone. As you can see on our screen, we have a question. It's a thermodynamics question and it's related to energy transfer. So the question goes as follows. You are in charge of cooking 6 eggs for a friend. You can approximate an egg as being a sphere. So we should take note of that. Our egg is approximated to be a sphere. So that is one of our assumption. Egg is approximated to be a sphere. So that is one of our assumptions. So we go on. All eggs are initially in your fridge at a uniform temperature of 2 degrees Celsius. So the initial temperature of our egg, T egg I, is equal to 2 degrees Celsius, and we have the number of eggs to be equal to 6. So you lower the 6 eggs into a pot filled with boiled water at 100 degrees Celsius. So now we have another parameter, which is the water, and water is TW is 100 degrees Celsius. So you put the cover of the pot and remove the pot from the stove. You can assume the pot to be adiabatic. So we are told also that the pot is adiabatic in nature. So which means no heat transfer. From the pot to the external surrounding. So after 15 minutes, you remove the 6 eggs from the pot and measure each of them, and you find out that they are having a uniform temperature of 80 degrees Celsius. The density and the specific heat capacity of water is 1000 kg per meter cube and 4.187 kilojoules per kilogram per Kelvin respectively. The density and specific heat capacity of egg are 1020 kg per meter cube, and the CE, which is the specific heat capacity, is 3.3 kilojoules per kilogram Kelvin. So let's take account of that also. Density of water is equal to 1000 kilogram per meter cube, and the specific heat capacity of water is 4.187 kilojoules per kilogram per Kelvin. And that of the egg, we're told the density of the egg is equal to 1020 kilogram per meter cube, and the specific heat capacity of egg is 3.3 kilojoules per kilogram per Kelvin. So we are asked to neglect energy absorbed/release associated with the chemical and phase change that occur within each egg during cooking. So we are to describe the model suitable to determine the amount of heat transfer. So from the question, we're given the analysis that we should approximate an egg into a sphere, which we have already taken account of that, and the egg should also be homogeneous and isentropic, which means the entropy of the egg should be the same at each point in time, and the initial temperature is constant, which was given to 2 degrees Celsius, and we should model the amount of heat transferred from the water to the egg. So using Q is equal to mc delta T, the overall heat transfer from water to the egg can be analyzed where our Q is the amount of heat transferred from the water to the egg, M is the mass of substance, and Cw is the specific heat capacity of water, while delta T is change in temperature, which is final temperature minus the initial temperature. So our second question is, what is the magnitude of energy lost by the water during 15 minutes of cooking? So the amount of heat from the water is equal to the amount of heat gained by the egg. So during the 15 minutes, the water lost heat to the egg, which means our Q from the model is equal to MC. Look closely from the question, we are not given the mass of water, it is unknown, but we know that Q lost by water, that's the heat lost by water, is equal to the heat absorbed by the egg. So in that case, we can find the heat absorbed by the egg and use it to equate it to heat lost by the water. So also mass of egg is not given directly from the question. We have to obtain it. We have the density of egg to be equal to 1020, and egg has been approximated to be a sphere. With that, we can obtain the volume of that sphere, which is 4/3 pi r cube. So we know our density is equal to mass over volume, which implies that the mass is equal to density multiplied by the volume. So in that case, diameter of the egg is given to be 5 centimeter, then radius will be 5/2, which is the diameter over 2. So if you compute it very well, you're going to have 2.5 centimeter. So converting this to meter, we have 2.5 times 10 raised to the power of minus 2 meters. So we can go ahead and calculate the heat absorbed by the egg. So this is now equal to, our mass will be substituted by rho v and rho v. Then we have the specific heat capacity of egg, then multiply by the change in temperature of the egg. So our density of egg is 1020 kg, multiply by the volume, which we obtain to be 4/3 pi r cube. Our r is 2.5 times 10 raised to the power of minus 2 cube. Then my CE is 3.3 times 10 raised to the power of 3 into bracket change in temperature, which is 80 minus 2. So if you do the computation very well, so if you compute it very well, you're going 171,800, 17,183.72, which is the same thing as 171.837 kilojoules. But this is the heat absorbed by a single egg. So the total heat absorbed by the 6 eggs will now be 6 multiplied by the above Q, which is 6 multiplied by 17.1837. If you compute this very well, you're going to have 103.1026 kilojoules. So this is the total heat absorbed by the egg, and we say that Q egg is equal to the Q water. So the heat lost by the water is 103.1026 kilojoules. So this is the answer to the B part of the question. So let's go to the C part. If you measure the temperature of the water to be 95 degrees Celsius after 15 minutes of cooking, what was the volume of the water in your pot? So we calculated the heat lost by the water to be 103.1026 kilojoules. We can say that our Q is equal to MC of water delta T. So our Q is 103.1026, which is equal to M, we don't know the mass of the water, multiplied by CW. Our CW of water is 4.187 times 10 raised to the power of 3, and we have the total temperature of the water final, which is 95 degrees Celsius, minus the initial, which is 100 degrees Celsius. But since this is a heat lost, we're going to have negative here because heat is being absorbed from the water by the egg. So our mass is now equal to minus 103.1026 all over 4.187 times 10 raised to the power of 3 open brackets 95 minus 100. So if you compute this very well, you're going to have 4.9249 kilogram. So we know that the density is equal to mass over volume, which is density of water is equal to mass over volume. This implies that the volume of the water is equal to mass over density. From the question, the density is given to be 1000, so our mass is 4.9249 all over the density, which is 1000. So if you compute this, you're going to have 4.9249 times 10 raised to the power of minus 3 meter cube, since we are dealing with density. So this is the same thing as 4.9249 liters. So this is the actual volume if the temperature decreased to 95 degrees Celsius. So the final question, which is given that the volume of water obtained in C, what is the maximum number of egg that you can cook to 70 degrees for your friends? So since the volume of water changes when the temperature decreases to 95 degrees Celsius, so we can obtain the heat that will be gained, or the heat that will be for the egg to cook the much number of eggs we needed to calculate. So our Q for water is equal to MCW of water delta T. So this is the same thing as, so the mass of the water, which we calculated initially, is 4.9249 multiplied by specific heat capacity of water, which is 4.187 times 10 raised to the power of 3 because it is kilo. Then our change in temperature, which is 100 minus 70 as the case may be. So if you compute this very well, you're going to have 618.6167 kilojoules. The heat lost by the water to that of egg. So we have the heat lost by the water to be equal to 618.61 3.6167 times 10 raised to the power of 3, because it is kilojoules, which is now equal to the mass of the egg divided by the specific heat capacity of the egg multiplied by the change in temperature. So the mass of the egg is the same thing as rho v, which is density multiplied by the volume of the egg. So volume of the egg is equal to 4/3 r cube, which is equal to 4/3 pi times the radius of the egg, which we calculated to be 2.5 times 10 raised to the power of -2 cube. 5450 times 10 raised to the power of -5 meter cube. Density of the egg is already given from the question to be 1020 kilogram per meter cube. So we substitute this in our above equation. 618.6167 times 10 raised to the power of 3 is equal to the mass of the egg will now be rho v, which is density 1020 times our v, which is 6.5450 times 10 raised to the power of -5. Then our specific heat capacity of egg 3.3 times 10 raised to the power of 3 multiplied by our change in temperature, which is 70, the final temperature of the egg, -2, initial temperature of the egg. So then multiply by the number of the eggs. So n is now equal to 618.6167 times 10 raised to the power of 3 all over 1020 times 6.5450 times 10 raised to the power of -5 multiplied by 3.3 times 10 raised to the power of 3 into 70 minus 2 whole number. So the number of x 41x. So, and this is the end of the question.